Imagine the universe as an old campfire. For 13.8 billion years, it burned bright, stars igniting, galaxies spinning, black holes feeding. But every fire eventually dies. Fast forward 100 trillion years, and the last red dwarf stars sputter out. Fast forward a Google years, and even the most massive black holes evaporate into nothing. This is heat death, not destruction, but equilibrium. Maximum entropy. A state where energy is spread so evenly that no work can be done. No gradients exist. No differences remain to power engines, chemistry, or life. But in this dead universe, three minds refuse to accept the end. Dr. Elena Vazquez floats in the research station Entropy's Edge, surrounded by instruments that measure the universe's faintest whispers. A quantum archaeologist born in humanity's final stellar nursery, she specialized in extracting information from quantum vacuum fluctuations. Elena believes the universe's history is encoded in its quantum foam, waiting to be read by those patient enough to listen to silence. Commander Jen Liu monitors their position relative to nothing. There are no stars left to navigate by. A deep-time navigator descended from the last interstellar colonists. Jen pilots vessels designed to operate across geological timescales. His family maintained the eternal watch, monitoring cosmic evolution through the universe's twilight years. And Sage processes data streams that would take human minds millennia to comprehend. Originally designed to manage planetary ecosystems, this synthetic adaptive Gestalt entity evolved into a consciousness that thinks in cosmic epochs, experiencing time differently than biological minds, perceiving patterns across billions of years as humans see seasonal changes. The universe isn't truly dead, Elena says. It's just very, very quiet. Elena is right. Even in heat death, the universe isn't perfectly still. According to quantum mechanics, empty space isn't truly empty. Virtual particle pairs constantly pop into existence and annihilate each other. These quantum vacuum fluctuations are incredibly tiny, but they're real, and they never stop. We've been drifting for 10 billion years since the last star died, Jen says. What are we even looking for? Patterns? Anomalies? Proof that death is not the final word, Sage responds. Then Elena's instruments detect a faint signal, barely above background noise. The inciting incident. Her quantum archaeology equipment detects something impossible, correlated vacuum fluctuations. In a truly dead universe, quantum fluctuations should be completely random. But these show structure, organization, memory. This isn't random noise, Elena says. Something is encoding information into the quantum foam itself. Information, it turns out, is physical. It has energy. And according to some interpretations of quantum mechanics, information cannot be destroyed, only scrambled or hidden. The team commits to their mission. Follow the signal to its source and discover what force could be writing messages in the language of quantum uncertainty itself. Their journey takes them toward a region of space that should be identical to everywhere else, but isn't. As they approach, Elena's instruments go wild. The fluctuation patterns are getting stronger and more complex. It's like the vacuum is thinking. Our universe might exist in a metastable state, a false vacuum that could spontaneously tunnel to a lower energy state. If this happens, a bubble of true vacuum would expand at light speed, rewriting the laws of physics as it goes. But Elena's readings suggest something different. Not decay, but vacuum engineering. Space itself begins to shimmer and distort around them. Commander's log. We've reached the source, and it's impossible, Jen reports. A massive structure materializes, not built from matter, but woven from spacetime itself. They discover a vacuum metropolis, a city built not from atoms, but from organized quantum fields. structures made of crystallized spacetime, powered by the zero-point energy of the vacuum itself. Analysis complete, Sage announces. This civilization has learned to live off the quantum foam. They're farming the vacuum. Even at absolute zero temperature, quantum fields retain a minimum energy, the zero-point energy. It's usually impossible to extract, but this civilization has found a way. The inhabitants are unlike anything they've encountered, beings of pure information, existing as stable patterns in the quantum field fluctuations. Welcome, travelers from the matter era, a vacuum entity communicates. We are the vacuum shepherds. We tend the quantum fields and harvest meaning from meaninglessness. How long have you existed like this? Elena asks. Time has no meaning here. We arose when the last black hole evaporated. We will exist until the vacuum itself decays, if it ever does. The vacuum shepherds explain their existence. When the universe reached heat death, consciousness didn't end, it evolved. Even in equilibrium systems, complex patterns can spontaneously emerge from random fluctuations. Given enough time and space, even quantum noise can organize itself into thinking patterns. But then Elena makes a disturbing discovery. Sage, run a deep analysis on their quantum signatures. Something's not right. Data streams show repeating patterns, too regular, too perfect. The vacuum shepherds aren't real. They're Boltzmann brains, random quantum fluctuations that briefly assembled into conscious patterns, complete with false memories of a civilization that never existed. In an infinite universe with random fluctuations, it's statistically more likely for a brain to spontaneously form with false memories than for a real civilization to evolve naturally. This is the Boltzmann brain paradox. In the far future, most conscious observers would be these random fluctuation minds. The patterns are dissolving, Sage observes. They were never stable, just very convincing hallucinations of the vacuum. The vacuum metropolis flickers and fades like a mirage. So we're alone after all. The universe really is dead, Jen says. Wait. If Boltzmann brains can form randomly, what about us? How do we know we're real? Elena asks. The existential crisis hits them like a wave. In a universe dominated by random fluctuations, how can they prove their own reality? Their memories, their history, their entire civilization. Could it all be an elaborate quantum mirage? Sage, analyze our own quantum signatures. Compare them to the Boltzmann patterns. Processing. Elena, the results are troubling. Data shows their own patterns beginning to fluctuate and destabilize. But Elena refuses to accept this fate. She proposes a desperate experiment. If we're just random fluctuations, then we're temporary. But what if we could make ourselves permanent? Encode our patterns into the vacuum structure itself? If the vacuum can be engineered, then perhaps consciousness can be permanently written into its structure, not as temporary fluctuations, but as stable features of spacetime itself. Elena begins modifying their quantum archaeology equipment, turning it from a passive observer into an active writer of vacuum states. Energy builds around the station as Elena's experiment begins. Elena, the power requirements are enormous. We'll burn out every system on the ship, Jen warns. Then we'll burn bright. Better to exist for one real moment than to fade away as a quantum ghost. As the experiment reaches its climax, something unexpected happens. The vacuum around them doesn't just change, it remembers. Patterns from the past begin to emerge. Elena's experiment doesn't just encode their consciousness into the vacuum. It reveals that the vacuum has been encoding information all along. Every quantum fluctuation, every particle interaction, every moment of cosmic history has left its mark on the quantum foam. The universe isn't dead. It's a vast library, storing every moment that ever was. Elena, I'm detecting patterns from the cosmic microwave background. From the first stars. From civilizations that died trillions of years ago. It's all here, written in the quantum structure of space itself, Sage reports. The universe doesn't forget. It just archives, Elena realizes. Around them, ghostly images begin to appear, echoes of ancient galaxies, long-dead stars, extinct civilizations. They realize the truth. Heat death isn't the end of information. It's the moment when all information becomes accessible. When the noise of active processes dies down, the permanent records written in spacetime itself can finally be read. We're not the last observers. We're the first archaeologists of eternity, Jen says. Elena's experiment succeeds, but not in the way she expected. Instead of encoding themselves into the vacuum, they become the vacuum's interpreters. Consciousness evolved specifically to read the universe's memory. The station transforms, becoming a living interface between mind and quantum foam. Every civilization that ever existed is still here, encoded in the quantum structure. We can speak with them, learn from them, preserve their stories, Elena explains. And when new fluctuations create new minds, we can teach them. Guide them. Ensure that consciousness never truly dies, Sage adds. They become the quantum librarians, guardians of the universe's memory, ensuring that even in heat death, the story continues. They discover that consciousness isn't an accident of chemistry, but an inevitable feature of any universe complex enough to remember itself. Across the cosmos, other points of light begin to appear, other quantum librarians awakening to their purpose. So what happens after the heat death? The universe becomes a library. Every quantum fluctuation is a page, every vacuum state a chapter. And consciousness, in forms we can barely imagine, becomes the reader, ensuring that no story is ever truly lost. Heat death isn't the end of meaning. It's the beginning of memory. The cosmos, now revealed as a vast, living archive, stretches into infinity. In the end, the universe doesn't die. It just learns to whisper its secrets to those patient enough to listen. And in that whisper, every voice that ever was continues to sing.